Hey, welcome back, folks. We're at part two for arcs and chords. So let's get through what we need to get through and get this new information to you. So, within a circle or incongruent circles, we have some new information. Chords equidistant from the center are congruent. So, if we have two chords and they're both the same distance from the center of your circle, that means that they are both congruent. Along with this, congruent chords are equidistant from the center. So, when we talk about this, let's look at these two chords that we got here. Chords go from one end point on the circle to another end point on the circle. So, if we have these guys right here, if these two are the same distance from the center, then that means that these two are also congruent. So, again, if we have two of them that are the same distance from the center, then those two are congruent. If we have two chords that are congruent, then the reverse is also true. They're also equidistant from the center. So let's talk about what we got going on here. Over on our example here, we got two chords here. We got this chord over here with X. We got this chord down here that has two sides that are marked the same, and one of those is marked 11. They want us to go through and figure out what's the value of X. So let's talk about what X is. X is this chord going from here to here. If we need this whole side, we got to pay attention to this other chord here. Reason being, these chords are both the same distance away from the center, 7. Since they're both the same distance away from the center, then that means both of these chords are congruent. So let's mark up some more things. These two sides here are both marked the same. So if this is 11, that's also 11. If these both are 11, what are they together? They are 22. So if these guys are the same distance away from the center, and we need to figure out what this other side is, they're both going to be congruent. So that means X is 22. It's a little less crazier than you probably thought. You just have to make sure that you pay attention to the information that you got. All right, let's look at a couple of examples, people. Make sure that you got your heads up on this. Let's take a look. In this circle, C, RC, and CE are both the following. They are 6 and 10 respectively. And ES is 8. They want us to find the value of AB and DE. So let's mark off where AB is, okay? I'm going to go through. We're going to use different colors just so we can get focus on them. So AB comes from here to here. And DE, this time we're going to use a little pen. DE comes from here over to here. Let's note some information we got. We got plenty of information that we got to go through and finesse out. So RC from R to C is 6. So we're going to put that 6 right here. CE from C down to E here is 10. And ES, which is down here, is equal to 8. We're going to need to go through and figure out some information here. So, what else do we know? Let's fit in all of our things here. We got doop, doop, and doop. Okay, turns out we already got this stuff popped up in the PowerPoint. I was just getting overzealous with the writing. It's better handwriting anyway. Okay, so we got these three aspects here. So if I have two of these sides, I need to figure out what this third side is. And what do I notice? This is a triangle that has a right angle. So if that's the case, let's figure out what this other leg is. If we did the Pythagorean theorem, we can go through and find out what that other side is. So 10 squared plus 8 squared is equal, sorry, not equal, plus this blank side here. We're going to call that side x, so x squared. When I go through and I need to get x by itself, I'm going to subtract 8 squared from both sides. So 10 squared subtracted from 8 squared, that is 36. When we go through and do that in our calculator, if 36 is equal to x squared, then that means that x is actually 6. So, if that's the case, that x there tells us that it's 6. Now, if that's the case, and this is 6, that means AB is equal to DE. So, let's go through, let's mark that up on here, and let's go and make some more sense of this. All right, if these two lines here from R to C and from S to C are both 6, that means that this chord up here and this chord down here, DS, these guys are both gonna be congruent. So we're gonna go and highlight that up real quick. So that means DE over here is also the same size as AB. If they're both the same size, that means that I need to figure out what this is. This right here is 8. That just like before, the other side is also going to be 8. This is 8. That's also 8. So that means that together these guys are both 16. Now, all this stuff, these properties are true for all the circles that we are going to do. If you're wondering how we got 8 for both sides, just like on our previous example, when we looked at this, these guys are coming through to the very middle of this chord here and the middle of this chord here. That's just something that ends up happening when we go through and do anything with circles. So that equidistance that we have there, it's not a coincidence this time. This time you could actually go through and say that. Okay. Next one. We got us a little bit of algebra that we got to go through to do. So this circle says RS here is 6x minus 2. And UV down here is 16. They want us to find the value of x. They did a little bit more of the hard work for us. They told us that these guys, these chords here, UV and RS, they're both the same distance away from the center. If they're both the same distance, then that means that we can go through and do just like we did before. We know that they're going to be equal. So, we set those two equal to each other. This time, we got this nice and easy. We take that 2, we got to bring it over for you, giving us 18. We divide by 6, and that gives us a 3. Nice and easy. So, all right, so just to recap, we covered the fact that chords are equidistant from the center, and that makes them congruent. If we have congruent chords, then that means they're equidistant from the center. Along with that, just know when it hits this line over here, this side and this side, they are both going to be the same length. Now let's go through and extend that with our next theorem. Within a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. So this is basically what we were just talking about. If we got a chord here and it is perpendicular to either a diameter or a radius, then that means that this whole chord here is bisected, and this arc here is also bisected, meaning it's cut in half. Let's get into a quick bit of algebra with this. So, on our paper that we got right here, we have this example. On this example, I noticed that this side here is perpendicular to this side, and that this side is x. So, let's figure out some information. If this is perpendicular to this chord, then that means that this chord has two sides here, 11 and 11, because it's being bisected. Now, if these two are going through and being the same size, we can also go through and extend off some more information. This side here is going from the center all the way to the edge, just like how this is. So this is us just using some more properties. All these lines that come from the center of our circle directly to the edge, they're all the same. All radii are the same size. So we could use this to figure out how big x is. So this is x, just like how that was. So let's do what we do best. We're going to do the Pythagorean theorem. X squared is equal to 11 squared plus 6 squared. 11 squared is 121. 6 squared is 36. When we add those two together, that gives me 157. 157 isn't a perfect square, so we're going to go through and take the square root of this and round as much as we can, probably to the nearest tenth. When we do that, we get about 12.5. So it's a little bit of extension with this. If we end up not having just a straight up and down easy problem to look at, we got to use the properties of our circle so we can set up some information and continue to solve. All right, let's get into our next slide. We got two examples here, so let's go through and make these clear. On circle C, this has a radius of 15 and AB is 9 meters from the center. They want us to find these two things. They want us to find AB and DE. So let's fit some information in here. They told me that AC was 15, so that's a line going from the center all the way to the end, so that's a radius. They also told me that AB is 9 meters from the center, so that means this little part here is 9. Now, we know a couple of bits of information. This line here, that's a diameter, and it is perpendicular to this chord. That means that this chord here, AB, is being bisected. And if that's the case, we can go through and figure out some other bits of information. Like when they said that this thing here, this radius was 15, that means that any other radius that we have on here is also 15. So that means that this, let's go through, let's going to turn this into something black. There we go. That means that this radius over here is also 15. This is going to come into play when we figure out how big DE is. So first, let's figure out what this side is. We got ourselves a right triangle, so let's go and Pythagorean theorem it up. We got 15 squared, that's our hypotenuse, is equal to 9 squared plus x squared, which is that side going from A to D. I got 225 is equal to 81 plus x squared. I got to subtract both sides by 81, which gets me 144, which means that x squared is 12. Now, that 12 is this right here. If this line here from A to B is being bisected, that means that if that side is 12, this side is also 12. Along with that, we know what the radius is. If this is 15 and from here to here is 9, what would this little part be here? We would just have to do 15 minus 9, which gives us a 6. So what is our answers? We got AB, which is those two 12s, making 24. And then we got DE, which is that 6 left over from that radius. So we were able to pick up a lot of information here, but we have to go slow and we have to take our time. All right, folks, we've taken it a little easy earlier. We've had some nice ones that had a lot of extensions, but this time we're going to have to go hard in the paint. All right, let's talk about what we got going on here. They want us to find the measure of this arc here, JL. Things that we do know. This diameter is perpendicular to this chord, JL. So that means it bisects this chord and it bisects this arc. Now, how are we going to figure out what this arc is? That's kind of a lot to figure out. It's kind of crazy. I do know one thing about arcs, and they are going to be made also by congruent angles. So what we're going to have to do is, if we could figure out what this angle that I just drew is, we could figure out how big this arc is. So how do we do that? This right here where we see this little triangle on our notes. This is a right triangle. It has a side here 3, and it has this side over here 6. So if we figure out what this angle is, we could also know what that whole big angle is together. All right, how are we going to do this? We're going to have to deal with some trigonometry yet again. So let's do some trig. If I wanted to find this angle here, I'm going to mark this one over here with this little orange block. Based off of this angle, 3 is our adjacent side. And this 6 is our hypotenuse. The only sides that use adjacent and hypotenuse for trig are cosine. So we're going to have to do our cosine to find this angle. And once we find this angle, we could end up going through and figure out this arc. So doing this, when we do the cosine of -1, that's going to be put in that 3 and that 6. That's going to give us 60. So that means that this little orange angle that we have here, this thing here is 60. Now, if this is 60, and I know that this arc matches up with this central angle, I know that this other side here is also 60. If this is 60 and this is 60, what are they together, people? They are together 120. So this big old angle here from J to K to L. Ugh, what was I drawing right there? Let's get, where is the eraser? There we go. Yeah. So this little arc coming from J to K to L is 60 plus 60, aka 120. Now, this angle has our center here, K, in it. That makes it a central angle, and that means that the actual arc is also going to be 120. All right, folks, finished right at the end of the bell. I appreciate you guys for watching. I'll see y'all later.